So the Lilliefors test for normality is a correction of the Kolmogorov-Smirnov test. It uses the KS statistic, but it uses a different method of calculating the associated p-value to make this test more selective and to make it more powerful. Power being the ability of the test to correctly reject the null hypothesis. Now, just like the KS test, the null hypothesis is that the data follow a normal distribution, and the alternative is that the data do not follow a normal distribution. So when we say that the Lilliefors test is a correction of the KS test to make it more powerful, we're saying that the Lilliefors test uses the KS test statistic, but it calculates a p-value that can correctly identify data that does not follow the normal distribution more often. But how does it do that? Well, we start with the KS test statistic, and if you remember from our video on the Kolmogorov-Smirnov test, the KS test statistic is the quantity of the distance between the actual data and the empirical distribution function and the expected, the cumulative distribution function. So it's the maximum deviation between that expected, that cumulative distribution, and the actual, the empirical distribution. So wherever that distance is the greatest. Then we use a p-value table and interpolation to calculate an associated p-value. Now, sometimes we can't interpolate. We have a p-value that's too high or too low. Then we will use an approximation algorithm to calculate that p-value.